Well, it's a very special honor and pleasure for me to be welcomed in this very nice way to the Academia Sinica in Taiwan. I first came here about 20 years ago, and I have been able to watch the remarkable growth and success of science in Taiwan, and I certainly will be delighted in my new role to do everything that I can to further cooperation around the world and to try to help to enhance the scientific advances in Taiwan, which are of benefit not only to Taiwan, but to the whole world. And so I want to talk about global sustainability in the future of Taiwan. And as you will see, and as I'll develop during the course of these remarks, I want both to emphasize the unique nature of the biodiversity of Taiwan and the need to attain sustainability in Taiwan on the basis of the living and non-living systems that control life here. But I want also to put that for you in a global context so that I can bring up a number of factors that I would recommend very strongly be taken more into account for the future of Taiwan. Guofeng Chang has presented a wonderful paper on Taiwan and has consistently in his teaching at NTU and generally been a great advocate and presenter of the biodiversity of this island. Like the coast of California, which is where I'm native, Taiwan reaches great heights because of being pushed against a deep ocean trench as the plates move out into the Pacific. And that gives it a variety, a geological variety that is incredible for such a small area. The biodiversity of Taiwan is rich and very diverse. And the Endemic Species Research Institute, part of the Council of Agriculture, has done a great job of presenting that biodiversity to a public in Taiwan that is about as interested in biodiversity, I think, as any public anywhere in the world. It's very popular, and there's very strong feelings here, as you all know, of relationship with biological diversity, which are very important. Now, in starting to talk about stresses on the world environment, human beings or our very close relatives have inhabited the earth for about 2 million years of its 4.54 billion year history, so we're recent newcomers, but even more recent is the advent of crop agriculture and the domestication of animals, which we now would date to about 11,200 years ago, or about 500 human generations. At the time when our ancestors first developed agriculture, the population of the entire world, which consisted of hunter-gatherers, is estimated to have been about 3 to 4 million people. 3 to 4 million people 11,000 years ago. 3 to 4 million people comprised the entire human population of all of the 6 inhabited continents and lived in small bands of hunter-gatherers, ever active in trying to find means to survive in a world that was supporting them but also could be very hostile and dangerous. As agriculture developed, people began to store food to tide over unfavorable seasons, and then they could stay in one place. They didn't have to keep moving in search of food or living a kind of a pastoral existence. And as they lived in one place, they began to form villages, towns, and cities. And in those villages and towns and cities were formed the beginnings of everything that we regard now as human culture, with very few earlier exceptions and carryovers. And so music, law, science, philosophy, storytelling, political, religious leaders, and all the other things that make up modern society originated over the last 11,000 years. Written language, in other words, everything that the Academia Sinica studies, and essentially, aside from prehistory and everything that we enjoy that make up the fabric of our daily lives. As that developed, written languages were formed about 5,000 years ago, but first in Babylonia, Syria, cuneiform writing, and along the Nile in Egypt with hieroglyphics. The hieroglyphics went only short distances up and down the Nile, really, but the cuneiform language gave rise to all the other European languages. When written languages were formed, people began to write down things that happened as they happened, but when they tried to write about things that happened earlier, they depended on storytellers. I find that, and the imagination changed on, and stories became more and more metaphorical. And I could find, even in my own life, and when I look back on things that I did in my 20s, and then I look back and see what actually happened, my memory has often changed them a fair amount. So when people were writing, for example, the Bible about 3,000 years ago, and looking back not only on whatever they had that was written, but on whatever they had that wasn't written, and trying to write it down, they obviously had to represent in the best way that they could what they imagined had happened before the time of King David's court, for example, in Jerusalem. Now, world population growth has been explosive since the time that agriculture was invented. At the time of Christ, it was about 2,000 years ago, which we base our calendar on. It's estimated to have been about 300 million people. At the time of the Reverend Thomas Malthus in England saying that our production of food could not keep pace with our population growth, it was about 850 million people. Of course, what helped us to keep, didn't entirely solve the problem, but helped us to keep pace with it, was the Industrial Revolution, the things that came from the Industrial Revolution, including the invention of mechanized plows, the ability to move water more easily from place to place, and particularly the synthesis, the ability to make synthetic fertilizers and other chemicals used to improve agricultural productivity. The global population didn't reach 1 billion people into 1804, and you can see by successive marks there, successive billions. The global population is now at about 7.07 billion people. And what is truly frightening, look at the stretch between 2011 and 2025 or 2043. From now until 2043, 2045, about 2 billion people will be added to the world population. About 1 billion people will be added in the next 12 years. About 500,000 of them in 500 million of them in sub-Saharan Africa, which at present has a population of about 950 million people, and where 500 million more will be added during the next 12 years, which is sub-Saharan Africa being virtually unmanageable now in terms of producing food and feeding the poor. Even though significant advances are being made, is facing an even more difficult future. Two other ways of looking at this population growth are that when some of us were born in the 1930s, there was a certain number of people, about 2.4 billion in the world population, and now, as we move on into a mature middle age, we'll say euphemistically. There are 3 people alive for every one who was alive when we were born. And what is even more frightening or needs our attention is that if you visualize everyone in the world as sitting down to dinner every night, tonight there will be 200,000 more people sitting down to dinner than there were last night. 2 days from now there'll be 400,000 more than there were today. And the drive will go on, even though the world in percentage figures passed its biggest population increase per year in 1971. The base has gotten larger and larger, and the numbers continue to rise just astronomically, which mean that whatever problems we have now are much more difficult than we imagine they are. Now, population is often regarded as the major driving problem, and of course population is fundamental. But population is by no means the only problem. The world is changing because of cities growing outward, and this is particularly difficult since cities were often formed in places where there was rich and abundant agricultural land, which is why the cities were put there in the first place. And as they spread outward, they're knocking off huge amounts of additional rich agricultural land. So, for example, in mainland China, during this 20-year period, 250 million people are moving into cities of 1 million or more people, and in doing so they'll be using up even more of the fertile land around the cities. So for instance, if you think about Hangzhou, Suzhou, Shanghai, and so forth, and even Nanjing, the size of those cities just gets bigger and bigger, and that's a lot of the very best agricultural land in China. Another way of looking at the human population is a picture from space rolled out from multiple copies where the light is, and there are very obvious evidences there of the density of people in our planet. One of the interesting points about this map that you might not notice, and which I could see on a recent visit, which I noticed on a recent visit to Pyongyang, is that North Korea is entirely unelectrified aside from a few major cities, and so South Korea actually looks like an island there, which is kind of funny and interesting, but it's not at all funny for the people who live in North Korea. The population that we have now, which is growing by 2 to 2.5 billion people over the next 40 years, is already racked with many, many problems: poverty, disease, drought, and famine. The levels of consumption of different people in different parts of the world differ drastically. For example, this is what a family in Western Europe consumes in the way of food in a week, which is much more, as we'll show, than their countries can produce. And this is what a family in West Africa consumes in a week. There are about, of the 7 billion of us now, there are about 1 billion who are malnourished to the extent that their bodies and minds brains do not develop properly when they're children, and their bodies are continually wasting away when they're adults. And of course, Taiwan has now gone up towards the upper end of the consumption spectrum, which is something that I want to return to later in a global context, and something that is very important for everyone to keep in mind. Another driver in the instability, in the insustainability of the world are the uses of technologies which were very good when they were first developed, like burning coal and burning oil and fossil fuels, and many production of chemicals, but which produce conditions now that are clearly causing the world to move further and further away from sustainability. with the world not seeming to be able to do very much about it. Now, biodiversity, which is the total number of plants, animals, and fungi and microorganisms with which we share the world, is essential for our lives. And if we are to build global sustainability, we have to build it not on the basis of more silicon wafers, but on the basis of biological diversity and the properties of living organisms. Yet we're driving those living organisms to extinction at an unprecedented rate. The last time so many of them were becoming extinct in such a short period was at the end of the Cretaceous period, 65 million years ago, and now we human beings are the only force that's continuing to drive them to extinction. And we need to consider how the process can be slowed down for our own benefit in the future. We cherish biodiversity because all of our food is produced by biodiversity. In fact, all of our food is produced directly or indirectly by plants. It may or may not surprise you to know that 103 kinds of plants provide 90% of our food directly or indirectly. And there are about 400,000 of them total, many thousands of which have been used for food by somebody at some time, and which might have a great deal of utility in the future. 3 kinds of plants, rice, wheat, and maize, corn, produce 60% of our food directly or indirectly. So we're using only a very small amount of the diversity that's available to produce food for people on Earth, which is one reason that we show we can depend on it and like to keep it around. In addition, the genetic diversity of our crops is extremely important. One of the ways that I often show this by analogy is saying that if avian flu virus entered this room and was spreading, it would affect only a small number of people. Why? If you look around you, you can see that the human race is hugely diverse. If a comparable pathogen enters a cultivated field that's completely genetically homogeneous, the effects are much more extensive, which illustrates why the kind of diversity symbolized by the contents of a corn crib in central Mexico is so important for the future. In addition, 2/3 of the people in the world, including the great majority of people in both China and India, depend directly on plants as their source of medicine. And even for those of us who buy drugs in the prescription drugs or drugs in the drugstore, 1/4 of them, and we'll look at a couple of examples in a minute, 1/4 of them were originally derived from plants or are still taken from plants, and another 1/4 were originally derived from fungi or are still taken from fungi or bacteria. So half of our prescription drugs have natural origins, as well as 2/3 of the people in the world using plants directly as medicine. In the age of molecular biology, we have to remember 2 sides of the question. Understanding genes, the way that they function and that the way they produce the phenotype of an adult organism, depends on comparisons between different organisms and different genes in different organisms. On the other hand, so that the diversity of organisms makes possible, the genetic diversity of organisms in a sense makes possible the diversity of our understanding of molecular biology. But on the other side, whatever we're going to build as a result of molecular biology, which as we all know is a science itself only 50 years old really, from the 1960s, will depend on the ability to find different kinds of genes and different kinds of transcription and different kinds of protein formation and on in other kinds of in diverse kinds of organisms. And the fewer we have, the less adept we can be in doing that. And of course, the recent announcement or discovery that the so-called junk portions of the chromosomes are filled with genes that are effective in regulating the the activity of the genes in the part of the chromosomes that seem to be active. Not surprising if you're a biologist, because things won't be wasted, but on the other hand, it's a huge discovery. And of course, another very recent field, recent in the degree to which we understand it, epigenetics, is also having a huge effect on the way we think about molecular biology at the present time. Organisms collectively control the flow of water. They control the landslides in central Taiwan. They control the keeping of topsoil. They control the fertility of the soil. They set local climates, and they have an enormous impact by providing what are called ecosystem services. In addition, a very large proportion of the foods we eat are pollinated by organisms that live in, that are part of the rest of biodiversity and could be regarded as part of the ecosystem services. Not to be missed is the fact that the beauty of organisms, the way in which we enjoy seeing them, the way in which we feel better if we're in a room that has a plant in it, or we enjoy the beauty of flowers, or we enjoy having a pet, or we enjoy having a fish in an aquarium, shows a kind of an ethical or philosophical relationship with organisms that enriches and nurtures our entire lives, which is really basically why we like to go for walks in the woods and see different kinds of places. A few examples of why every species matters. Aspirin was first developed by people noting that Europeans were chewing willow bark, and then soon isolated and synthesized in a form that would not burn out the inside of your stomach, which was a convenient thing. The venom from the green mamba, which is a deadly poisonous African snake, may provide a drug to prevent kidney failure during treatment for acute heart failure, where the treatments for acute heart failure have to make your kidneys fail and then you die. It's already come up, it comes up in the introductory film for Academia Sinica that warfarin, or Coumadin, which so many of us take for high blood pressure, was first discovered in a bale of moldy sweet clover, and of course is a powerful rat poison and effective blood thinner. Guar seeds, guar is a legume that's cultivated in India, provide ingredients for the materials used for fracking, for breaking up rocks and extracting oil and natural gas from them, used widely in the US and elsewhere. And very kind of interestingly and strangely, it's recently been discovered that the yeasts that occur on grapes come back every year and make the grapes of particular areas have their distinctive aromas and tastes, are taken away by wasps to their colonies during the winter, and then brought out by the wasps to the maturing grapes, and they're ready to be stomped into the delicious wines that can be made from them, and that differ so much from place to place. However, the species are disappearing very rapidly, unfortunately, while we're just beginning to learn about ways in which they can be useful and ways in which their integrated activities make life on Earth possible. They're disappearing because of habitat loss. Because of habitat loss, which is the major cause of extinction, because of air and water pollution, and of course, 40 years ago in Taiwan, pollution from many small factories was really widespread, but has largely been brought under control, fortunately. Because of alien invasive species, pests and diseases, which come in and knock off biological diversity, because of excessive hunting, think of bushmeat in Africa, or think of all the turtles in Southeast Asia being caught to bring them into China so they can be eaten there, and overgrazing, and now, very importantly, and we'll say a bit more about it for that reason, global warming, which is second only to habitat loss and may, during the course of this century, emerge as the major reason for biological extinction. So clearing of habitat for a whole variety of reasons destroys many species. And I'll say what we know about species later, but we've named about 1.9 million of an estimated 12 million species of eukaryotic organisms. And that means that if you clear tropical rainforest, about 19 out of 20 kinds of organisms will never have been given a name, will be completely unknown. And look at this scene, and I'll return to this theme. It's great that forestry in Taiwan has been outlawed for a number of years. It's awful, as everybody knows, that in the Japanese period here, so much of the wood was taken away to Japan and so many forests were killed. But on the other hand, all the wood that you import to Taiwan, which is virtually all the wood you use except bamboo, is taken somewhere else and is driving instability and the extinction of species there. And the point that I'll be making as I go on, one of the major points is that Taiwan needs to be sustainable itself, but it cannot be sustainable if the world is not sustainable. So that all the countries from which you obtain things have to be considered also in terms of their sustainability, or it simply comes to an end. There's no more wood, there's no more anything, there's no more things to import, people are just poor. Women and children in the developing world spend most of their lives gathering and bringing in water or firewood, and in doing so are completely deprived of their position in society, and also sort of totally denied the possibility of getting an education. This is a completely unjust situation, and one that the world really needs to rectify as part of its effort to gain overall global sustainability, because we need the individual contributions of their minds, and we can never get them either for the benefit of their own area or for the benefit of the whole world if all they do is this. Now here's a map of the destruction of tropical forest worldwide, and you can see that tropical lowland forest has been most heavily destroyed in Southeast Asia, with huge flows of wood going to China, Taiwan, Japan, and elsewhere in the world, and with relatively little forest left. So we can know that there's been an enormous amount of extinction there. It's spreading rapidly in Africa, and Latin America is the last area that still has substantial lowland forest. But it's going pretty rapidly too, even though in Latin America they've come closer to sustainable population and doing the other things that are necessary to win sustainability. You have a wonderful example of invasive species here in Mycania micrantha, which is a relatively recent outbreak, I guess 20 years. It's been spreading in Taiwan and now covers huge areas all over the lowlands of the island and is spreading up into higher and higher elevations. And as you can see, nothing else in that community has much chance of getting anywhere. This is an example of a pest. This is southern oak death, Quercus, which is killing oak trees and changing the characters of the forests in the Pacific coast of North America from California northward. It's a Phytophthora fungus that's introduced from elsewhere. And this is the emerald ash borer, which is killing all of the trees of Fraxinus in the northeastern United States and spreading through the United States, and it comes from Asia. What I want to point out, and this is, I think, very important in terms of what I'll say later, is there are completely insufficient numbers of specialists in different groups of biodiversity in Asia. For example, this is Buprestidae, but in the beetle family Scolididae, which are the ones that engrave the burrows underneath the bark of trees, and which are the major, probably the major pest of forest trees and for forestry. There are about, there's one retired specialist on the, and there are about 20,000 species. There's one retired specialist on the family in Taiwan. There are none in mainland China, and there's one retired specialist on the family in Japan. And yet this is a family that's causing enormous damage all over the world. And of course, if you want to talk about fungi, which are the major destroyers of anything built of cellulose in the world, in the United States, you could point out that fungi in the Pacific Theater caused more damage to the American war effort in World War II than all the Japanese military actions put together. And yet the number of specialists, people really knowledgeable about fungi and able to apply that information in the world is very, very poor. And I would very much urge Academia Sinica and the TESRI, the Endemic Species Research Institute, to think very hard and very carefully about what kind of specialists are needed from both scientific and economic reasons in order to handle biodiversity, which we're smashing to pieces intelligently. This is both ecologically in terms of sustainability and in terms of more immediate economics incredibly important. And then I just put a picture of ginseng as one of the plants that's overgathered in nature and just sort of coming to be accepted as a cultivated plant. I was interested in a recent visit to mainland China to have people saying they prefer cultivated ginseng from Wisconsin because that used to be like nothing, like bad stuff. So the transition is being made, but still in China and India, only about 1/6 of all the plants that are used as medicine are actually grown in cultivation. All the others are gathered or overgathered in the world, in the wild, in nature. And given the increased interest in all these herbs in the industrial world, in Europe, Japan, the United States, Canada, and so forth, the pressure on them has gone up monumentally. And then there's global warming, making it harder and harder, presumably for the polar bear on the right to jump over to join his friend on the left. But joking aside, these are various scenarios for global warming. As you see, this goes back to the year 1000. The last red line there is, this is all determined by satellite and world calibration. So, and here are various scenarios for global warming. At the last meeting on global warming, people agreed to revisit the subject in 2020, which is a scandalous situation to begin with. And they talk about a 2 degrees Celsius world. But people who actually work with global warming think a 2 degrees Celsius world is completely unattainable, and that a 3-degree world might be attainable somewhere around here. But on the other hand, there's very little evidence that people are doing anything about the burning of fossil fuels, much less the logging of forests and the release of carbon dioxide from the forests and all the other things that are going on. And so we could hit a 5-degree world, and I'd state right now that or more, there's nothing that will stop it there if we don't begin to be active. And I'll state right now that in a 5-degree world, mollusks, oysters, clams, and so forth, and shell and shrimp, lobsters, and so forth will be unable to form their shells in the ocean for instance, and will all start disappearing massively. And that's the kind of thing we have to face, which makes it a complete scandal that the United States has defaulted on leadership in the area of addressing global warming, when probably it's the one country that could really drive Europe and Japan and the other countries to action. But of course, you can't do anything about that except give a moral example, act internally to do whatever you can, and give a moral example to the rest of the world. Pat and I traveled with a group of scientists to Shishmaref Island in the Arctic Ocean on the north shore of Alaska to see firsthand the effects of global warming. And the group also included religious leaders and so forth, because we wanted to see it and talk about it together. And what we found is that this island, which has been inhabited for 6,000 years, shoreline has receded by 200 meters, and the village itself is falling into the ocean block by block as the permafrost melts off, which is pretty frightening. Headlines 2 weeks ago indicated that Arctic ice has shrunk this year to an all-time low. The 30-year average is the yellow line, and you can see where it is now, which is absolutely amazing. On September 16th, and that was 18% lower than the earlier low 4 years earlier, which in turn was 22% less than the low before that. And so it looks like all the Arctic ice is going to be gone very soon. And of course, that's very scary, both because the water absorbs more heat if it's bare, and also because it just indicates that ice melt is going faster. And the ultimate point is that if all the ice in the world melted on big sheets in Antarctica and Greenland and the Arctic and all, there would be an 80-meter rise in sea level around the world. 80 meters is pretty severe and pretty intolerable, but the question becomes, with a big lag effect in the effects of our actions, where we begin to deal with this. Here are some projections of farming in a warmer world. Remember that 1 billion people in the world are already malnourished, and the darker brown it is, the poorer farming will be in the future. It'll be better in the dark gray, but as you can see, the losses hugely offset the gains, and in fact indicate the urgent need for improvements in agriculture right now, because where are we going to get the food? All of the alpine and subalpine habitats in the United States with permanent snowfields or ice fields or glaciers in the lower 48 states will be gone, according to climate projections, and no matter which projection is followed, by the end of this century, during the next few decades, really. And of course, that's where Taiwan comes in very strongly also. As Guofang Chung has shown, and as those of you who work with this will know, the number of species in Taiwan decreases with elevation, but the proportion of endemic species in Taiwan increases with elevation, so that the dark bars on the left are the numbers of species that are found only in Taiwan at each elevation. These are plants, but animals, to the extent that we know about them, follow these rules. So that when you get up to the alpine regions, 3950, near the tops of the mountains, 60% of all the species are found only in Taiwan. And when you're down in the lowlands, which have been, of course, the most damaged ecosystem as human activities in farming and all have spread, the corresponding figure is about 1/6 are found only in Taiwan. So here's the upward increase in the proportion of plant endemics in Taiwan. And here are some of the beautiful flowers that occur in those alpine and subalpine regions. And here's an example of the research that's being done, partly at the Academia Sinica and C.H. Joe, who's here, is certainly an active person in investigating this phenomenon. And the picture is not pretty because it shows that all the trends indicate that most or all of those alpine and subalpine species are likely to disappear during the course of the next few decades. And the future of those communities is very, very dim. Here's a plant in the same family as celery or parsley that Guofeng studied, Chirophyllum involucratum. It grows under those tall conifers on Mount Snow. Here is its present distribution. The dots are places where it's been collected now, and the dark area is the sort of area of potential range. Here its past distributions, the last glacial maximum as projected by climates at that time, and you can see it was considerably larger than it is now, and it's been pulled into its present area. But here's the really damaging calculation, which shows that under the 6 different climate scenarios shown there, which are like the ones shown on the earlier slide, the species will completely disappear or nearly disappear in about half of them. And you know that the drive goes on. We don't really know how warm it's going to be, but it's very, very, very bad for the future of those organisms. And that can be demonstrated very clearly, as it has been in other parts of the world. As to sea level rise, the sea level has been rising since about 1850 as a result of the Industrial Revolution. And ironically, by the way, it was in 1895 that Swedish Nobel Prize winner Arrhenius first pointed out that greenhouse gases would drive global warming in 1895, which we're still arguing about it. And again, here's sea level by satellite in the red bar. These are calculated by summing other kinds of figures. And it goes on directly. According to the Intergovernmental Panel on Climate Change, IPCC, sea level is likely to rise 1.8 meters during the remainder of this century, with it accelerating as it goes along.